Hey guys, Ryan here. If you've been hearing people talk about AI agents over and over for months now, you'll be aware that these things are quite powerful. But the problem is, no one even shows you how to build your own AI agent, or even why. Why don't I just stick to ChatGPT, or why don't I stick to using Claude? In this video, I'm going to be walking you through how to build your own AI agent from scratch. I'm going to go through the whole process of what an agent is, to what frameworks to use, and to why it's even useful to build your own agent rather than use ChatGPT or Claude. We're going to be talking about the frameworks that make sure your agent doesn't go rogue. So this means adding human in the loop, adding auditability where the agent's actions can be seen across multiple steps and stages that and actions that it takes. And we're going to make sure that we'll be able to directly plug in these agents, not only just to make them, but plug them into business applications. And you can see the different use cases that there'll be with these agents. By the time we finish with this video, you'll end up with a new framework or a new idea of how you can make your own agents for your business.
So, first things first, what is an AI agent, right? So, think of it like this. What's the workflow right now? Is you probably have a prompt in, and then you probably have something like ChatGPT. You put in your prompt, say, for example, what time is it in Canada? Or actually, let's give a practical example. What is today's agenda, right? So, you go into ChatGPT and you say, what's today's agenda? And ChatGPT or Claude comes out with, and you'd ask, why would it say this, right? I mean, it's fairly simple. It doesn't have access to your calendar. How could it know something without context? And the keyword there is context, right? You can have the most powerful model in the world, as these models are getting better and better with ChatGPT and Claude, but without context, it becomes very irrelevant. So not very useful, right? So that's where an AI agent comes in. And let's look into what this means. So, an AI agent is different because anytime you ask the same question, what is today's agenda? The AI comes back with the answer. You've got a 9 a.m. meeting, or and then 10 a.m. gym. I don't know who goes to the gym at 10 a.m., but fair. And then 12 p.m. you have, let's say you have another meeting. Now, difference is here, it has context because you're connected to your Google Calendar or your Apple Calendar or whatever calendar you use. So the difference with an AI agent and any normal ChatGPT conversation you'd have is that it has access. And this access gives it context. So this is AI agents. And a very important part to figuring out what really is the difference between this and the one before is everything is now looped. So it's feeding data in, feeding your tools in, and then looping at a problem iteratively until you solve it. That's essentially what everything mostly is with agentic AI. And I mean, before it was simply you just add your prompt in, you send a prompt to ChatGPT, which is, hey, what's the weather like in Sydney? And the LLM would come out with an output like, hey, it's 19 degrees in Sydney right now. But now we're moving to an iterative loop system where not only does it just spit out information, it is now capable of thinking and really planning how to answer you based on what you ask it. And not only that, but it's also capable of using tools. I mean, the LLM basically connects to your tools. Diagram illustrates it perfectly. The LLM connects to your tools. Your LLM could be anything from Claude, ChatGPT, or anything you favor as your favorite AI model. And then it uses your tools to act on the action you ask it to do. For example, you'd say something like, what's my agenda for the week? And your tool there could be Google Calendar, like I said earlier. And it will basically use your Google Calendar, try to access it. If it fails, that's an observation. It's observed that there's a problem
And another part that's going to come in later is that it stores that observation in memory, and then it sets objectives. That's where the fourth section comes in, where it sets objectives for what it's just done or what it needs to do. So in this case, the objective would be fix the connection. Objective would be fix the connection on LinkedIn, on Google Calendar. So it essentially iterates on this process continuously until it solves a problem and comes back with an answer. That is, your agenda for the day, for the week is you have Monday planned for interviews, Tuesday, yada yada yada. So, I mean, the big next leap from this is simply just adding memory. So it's easy to see that in order for you to track and set objectives and improve on something, you have to remember your failures, right? Michael Jordan would make one mistake in one game and simply improve on that one mistake for the next game. So it's simply not making the same mistakes twice. That's where memory comes in. And an interesting topic with memory is a new innovation. And skip over this. We'll call it. It's now called vector databases. It's quite interesting how these work. Normal databases are two-dimensional. You work on a 2D plane. Columns here, and then your rows. So say you'd have first name, last name, and then you'd have the first record, second record. But now we've currently evolved to a three-dimensional plane, which is information gets stored in a 3D plane, and you'd ask, why does this even improve things? Doesn't it just complicate? Now you're able to use maths, right? And you could use a bunch of numbers to group stuff, and then you'd be able to tell that even though something isn't exactly the same, they have the same meaning. For example, happy and ecstatic. Not the same words. That's something you'd search in a 2D plane where you just search for the actual word, but have almost the same meaning. And that's where you'd find these two groups in the same dimension. And that's exactly how the AI interprets this vector database. It stores it semantically in numbers, right? Could be numbers that are quite close together, but not really. Almost like this, where you'd have 12, 18, 14, and 0, 1, 0, 17, 14. So kind of close, but not the same. That's where semantic comes in. You're not able to piece together that things are the same, but exactly, but you know they're related to each other. That's where the innovation of vector database came. And that's what Pinecone is in this case, where you store historical outcomes and user preferences across multiple sessions. And that's how you get AI to have more of a feel to it, more of a better user experience, that is. Later, we're going to discuss where the practical application within a business this lies in. But very interesting concept, I think. After doing all that, we can understand that the whole process is a workflow of defining your goal, instantiating the LLM of your choice. And then you trigger a plan. After it does its planning, you trigger a plan. And then you execute your tool, and then it loops. There's a loop, which is this decision tree. And eventually a resolution. Or worse than this is you did not have a plan for when it goes through too many iterations. That costs you money. We'll come to that in later episodes. The loop is infinite, and that's a problem. So that's where a few frameworks have started to come in. So with AI agents, in a nutshell, what we just talked about has been done already by a few companies, and I'll show you a few of them later on in the video. I mean, LangGraph has been the best framework at scaffolding these AI agents together. You're able to set up agents from scratch, set up memory, tooling, as well as auditability, because the Lang framework allows you to set up observability of which tools it used, what the thought process was when it used that tool. And True AI, I don't have experience with, but I also hear quite good things about it. I think the founder is Jack Altman. Yeah, that's it, Jack Altman.